Welcome to clickmyproject.com. Our product title is Design and Implementation of a Novel Multi-Level DC to AC Inverter. Now we are going to see our product abstract. In this paper, a novel multi-level DC to AC inverter is proposed. The proposed multi-level inverter generates 7-level AC output voltage, and then we are using the low pass filter is used to reduce the total harmonic distortions in SPW output voltage. The switching losses and the voltage stress of a power device can be reduced to the proposed multi-level inverters. These operating principles of a proposed inverters and voltage balancing method of input capacitor are discussed. Finally, the multi-level inverters, we are giving the input for example 400 voltage or 440 voltage. So we are giving the input, the output we are getting the same level, and then 220 voltage VRMS. The VRMS equal value equal to voltage or output voltage divided to root 3. So we are getting the 220 voltage. So nearly we are giving the voltage 400 and get the voltage 390 380 voltage, so AC voltage. And then the result of the high technology development, the demand the quality of electrical power and higher before. So because the purpose of the multi-level topology is to reduce the voltage rating of the power switch. Therefore, they usually use the high power applications by combining output voltage, the multi-level form. It has the advantage of the low power and low input current distortions and lower switching frequency. As a result of advantage of multi-level topologies, seven layer topologies have emerged the increase the output voltage AC. The novel of the multi-level inverter is designed and implemented in the paper. The major feature of the proposed topologies is reducing the power components. This controllers SPWMs is used to control proposed circuit by the signal processing. And then the proposed the novel tech topology used the 7-layer inverters. The input voltage divided the composed the 3 series capacitors C1, C2, C3s. So this is hybrid with the MOSFET. We are using the 4 diode, and the voltage is sent to output terminal, and by high bridge MOSFET. The proposed multi-level inverter generates the 7-level AC output voltage in the gate signals designed. Now we are going to see our product flow diagram. So our flow, we are giving the input for the source DC voltage, input voltage for like 440 voltage, and then it will be the renewable energy source also. And then we are going to the converter the process. The converters, whatever the we are giving the input voltage the DC, and we are getting we will be get output for the AC voltage. So it's a DC to AC inverters and converters models. So we are in the designs and implementation of multi-level DC to AC. The multi-level using the switching operations. So we are using the controllers SVPWM. So in this process we are getting the switching pulse for zeros or swans. So whatever the functions is related to the 1 by root 3 output voltage, and then the root 3 by 2 the voltage output voltage. So we give the many switching operations for the like SVWMs. So this is a sine way to get the output of voltages, reduce the voltage rating the power switch. So this inverters models is going to the input current and distortion the low switching frequencies, and the new topology achieves the reductions in this number of power devices and voltage stress comparisons between the two inverters, and then the present of the number components recommend implement is 7-level inverter using the proposed topologies. Since the voltage deviations cause the large harmonic distortions the output voltage, the voltage balancing circuits is inside capacitor of multi-level inverters by using the switching capacitors converters. The voltage balances of input capacitors is achieved in the circuit configuration of a unit of switching capacitor configurations converters. The duty cycle of every switch is equal to the 50% of the voltage C1 capacitance and C2 capacitor voltage, and then current of C1 is higher than the C2. So switching operations is cycle to most number of charges flow in the switching cycles. And then we are using the load. We are using the any type of load. We are using resistor values, inductance, so whatever maybe we are getting the output is balanced to those cycling model and cyclings and get the output for AC voltages. Now we are going to see the running process for our product. So this is our MATLAB 2009 version MATLAB tool. This is the simulating tool. You are getting all components parameters values from here only. So this is our main.mdl. This is our main coding. So this is a simulating library process. So here we are searching any kind of parameters we are getting from here. Now I am hide the processes designing. So I have seen the black panel file here. So this is I have hide my designing process, and then our process is DC to AC converters. So inverters models, we are giving the input for 400 voltage DC source, and then we are MOSFET switching gears, and then 3 type of capacitors and 4 diodes. So this is we are transform using and get the DC to AC transform using bridge rectifiers also we are using here. And then the inverter we are using 440 voltage AC DC voltage and get then 220 voltage VRMS value of output voltage. So 220 voltage VRMS output voltage. And then so now we have to see in the scope of functions. So this is output voltage. So 0 to 390 voltage approximately. So 390 voltage. So the RMS value equal to voltage output voltage divided by root 3. So 400 divided by root 3 equal to 220 voltage. So 220 voltage VRMS value we get it. And then input voltage also here has in here. So this is the input voltage for 440 voltage input voltage. So for input voltage for 440 voltage, and then output voltage for 390 approximate 390 something. Okay, and then we are using space vector pulse width modulation. This is a switching operations. About to see so this is the switching operations process. So this is a bit level for this time we will get enable and off conditions, enable disable. So this is an operation switching combination 7 layers, 7